Welcome back. Today we will be discussing the standard form of a quadratic equation, which you see here, y equals ax squared plus bx plus c. We've already discussed what different parts of it do, a and c, and we'll get to that here again in a minute. Today we're going to talk about really how we can use that in order to find things like the axis of symmetry, of the vertex, different items like that. Let's start with what we already know. We know that the standard form of a quadratic equation is y equals ax squared plus bx plus c. We've talked many times about that. We know that if a is greater than 0, if the coefficient of x squared is greater than 0, we have a parabola that points upward. We know that if a is less than 0, we have a parabola that opens downward. And by now we know that c, this final part, is the y-intercept. It's going to determine where on the graph our line is going to cross the y-axis. So one like that might be something that was x squared minus 2. Okay, but c will give us the y-intercept. We also know the axis of symmetry. We have x equals negative b over 2a. We've also talked about the different terms for x-intercepts. X-intercepts where the parabola is going to cross the x-axis is also known as the roots, the solutions, and the zeros. Alright, so let's start off with given y equals negative x squared plus 4x minus 3. Now we want to start by finding the axis of symmetry. And again, the axis of symmetry is going to be x equals negative b over 2a. So to find that, we're going to have x is equal to negative b, which is 4, over 2 times negative 1, because x here is negative 1, or the coefficient of x squared is negative 1. So we're going to have negative 4 over negative 2. And that negative can go either way. Basically, this is 4 divided by negative 2, which is negative 2, and the opposite of that would be 2. So our axis of symmetry is x equals 2. Next, we'll work on the vertex. Now, we just found that x is equal to 2 is the axis of symmetry, which also means the vertex is going to have 2 in the x coordinate. So what we can do is we can take that information and we can plug it in here, because this is just an equation. So we're going to have y equals negative 2 squared. Now this is a little bit different. You notice I put the parentheses around the 2. Normally I would tell you put the parentheses around the minus 2. But since this is negative x squared, we're talking about the opposite of x squared, and x is equal to 2. So it's going to be the opposite of 2 squared. And then we're going to continue on. Plus 4 times 2 minus 3. So that's going to give us 2 squared is 4. So the opposite of that is negative 4. Plus 4 times 2 is 8 minus 3. And that will give us a total of 1, because negative 4 plus negative 3 is negative 7, plus 8 is 1. So we get a y of 1, which gives us a vertex of 2, 1. Next, we're going to take it and we're going to go ahead and graph it. We're going to actually find some other points to go with it as well. We've already found that our vertex was 2, 1. And since our vertex is 2, 1, that means our axis of symmetry is 2. So I'm going to go ahead and write that here so we have it. Alright, we'll find on the graph 2, 1 is right here. Our axis of symmetry is along this line. Not well drawn, but close enough. We also know that this is our y-intercept, which means our graph goes through that point right there. Our parabola goes there. And since we know that, we can also find a reflecting point. If this point is reflected over the axis of symmetry, it's 2 units over. That means we're going to go 2 units this way. We have another point. So at least now we have a start to our parabola, and we can graph it like this. Now to find more, the easiest way to do that is simply plug this into the calculator, and you can find the x-intercepts. Next, let's look at a different type of question. Here we have the vertex being at 3, negative 7. We also know that one intercept is going to be at 9. The question is going to be, what's the other intercept? So we can use our graph to do this one. The vertex is at 3, -7. So here's 3 and down to -7. So right there. We know that one intercept is at 9, which is going to be here. The question is, where is the other intercept? Well, this is the vertex. That means we have our axis of symmetry right there, which is our midpoint. It's right in the middle of the parabola. Well, if this is one intercept, that would mean the other intercept would have to be reflected across the axis of symmetry. And this point is 6 units to the right, which means our other point would be 6 units, 1, 2, 3, 4, 5, 6 units to the left. So the other intercept is going to be -3. Now hopefully, but while you're watching this, you're realizing there's a quicker way to do that even than just graphing it. Our midpoint's at 3, one intercept is at 9, that's 6 away. All we have to do is subtract 6. 3 minus 6 gives us -3. So you can calculate it without actually having to graph this. So keep that in mind. Let's go at it a different way. Here we have 2 points of a parabola are located at 4, 3 and -6, 3. And the question is, what is the axis of symmetry? So again, let's go ahead and graph our points. 4, 3 will be right there. And -6, 3 will be here. The question is, what is the axis of symmetry? Now, using the same information that we just discussed a minute ago about knowing the vertex and one of the intercepts, we just reflected it. We can do the same thing here. We know the 2 endpoints. We now need to find the midpoint. So we can look at this and think from -6 to 4, that's 10 units. We want to go to the axis of symmetry, which is going to be halfway, which will be 5 units. And that should be right here at -1. That means we don't know the vertex necessarily, but we do know that the axis of symmetry will be x equals -1. Just the midpoint between the 2 points. Because again, remember, these points, because it's symmetrical, they're going to be reflected across the axis of symmetry. So you're going to be able to find that axis, or to find the axis pretty easily just by the midpoint. All right, in conclusion, pretty much what we've talked about several times before. Remember that everything is intertwined. That's a great thing about math. Everything's always going to be intertwined. But in this case, our vertex is going to be related to the axis of symmetry. The vertex, the x value will be the axis of symmetry. We can use the x value of the vertex by plugging it into the equation if we know it to find the y value. And finally, we can always reflect points across the axis of symmetry. That's the great thing about it being symmetrical, is that when we reflect it, when we find one point, we've actually found 2 points. So what I'd like you to do is continue working through the packet. Also, start playing with the calculator. Start playing with some different equations. Get better acquainted, or continue to be better acquainted to what's going on with the A, the C, and start looking at the B, how the B will affect it. Thank you.